Today's lesson on special right triangles is all about 30, 60, 90 right triangles. In the first example, we have side length 5, which we'll call A, side length X, which we're trying to solve for, we'll call that B, and side length 10, we'll call that C because that's our hypotenuse. So, setting up our equation, we have 5 squared plus x squared equals 10 squared. We solve for x squared by subtracting 25 onto both sides. X equals square root 75. That breaks down into square root 25 times square root 3. X equals 5 root 3. In our second triangle, we have side lengths A, B, and C. We'll solve for side length x with the equation 4 squared plus x squared equals 8 squared. 16 plus x squared equals 64. X squared equals 48. Take the square root both sides. X equals square root 48, which is 16 times square root 16 times square root 3. Final answer is 4 root 3. In a 30, 60, 90 triangle, the ratios are 30 to 60 to 90 degrees. The side ratios are 1 to root 3 to 2. I'll show you what that means shortly. Look to the right of your screen. In a 30, 60, 90 triangle, the shortest side is always across from the 30-degree angle. The longest side is always across from the 60-degree. The longest side is always across from the 60-degree angle. Now, of course, we know the hypotenuse is actually the longest side, but when it comes to the legs, we have the short side across from 30 and the long side across from hypotenuse. And we also, across from the 60 degrees. And then we also have the hypotenuse across from the 90-degree angle. As you can see in the triangle on the left, we only know one side length. It's a side length across from the 30-degree angle. Even though it's not marked 30 degrees, we know it's 30 degrees because we know we have a 60-degree angle and a 90-degree angle. The first thing we need to do to solve for M and K is set up what we call a reference triangle. A reference triangle is a 30, 60, 90 triangle with our side ratios of 1 across from the 30 degrees, square root 3 across from the 60 degrees, and 2 across from the 90 degrees. This is our ratio for 30, 60, 90, 1 square root 3 to 2. So, to find the first M, we have 4 over 1. 4 over 1 represents the 30-degree side length over our reference degrees 30-degree side length. M over 2, we set that equal to M over 2. M, our hypotenuse on the left, equal to 2, our hypotenuse on the right. Okay, so we have our 30-degree 4, our 30-degree 1, equal to our hypotenuse M over our hypotenuse 2. Now we need to solve for M. We solve for M by cross multiplying. So we have 4 times 2 equal to M times 1. So we're left with 8 equals M. So now we've solved for M. We need to solve for K. So to find K, set up the ratio again. 4 over 1, which is our short side of the left triangle over short side of our reference triangle, equal to K, the long side of our triangle, over square root 3, the long side of our reference triangle. We cross multiply. 4 times root 3 equals 1 times K. 4 times root 3 is 4 root 3, and that equals K. In example 4, the very first thing we need to do is set up our reference triangle. So we have set up our 30, 60, 90 triangle that looks just like the 30, 60, 90 triangle in example 2, except that we're using the ratio 1 across from the small side, square root 3 across from as the long side, and 2, the hypotenuse, the same ratio we used in the last example. And this is our similar triangle. Let's first start by solving for G. So 18 over 2 equals G over square root 3. 18 is our hypotenuse on the triangle on the left, over 2 our hypotenuse on the triangle on the right, over G, long side hypotenuse on the left, over square root 3 long side of our similar triangle. So 18 over 2, we're just going to start by simplifying that because that just equals 9. So we're going to rewrite the equation now as 9 over 1, same thing as just 9, equals g over root 3. Cross multiply here, we have 9 times root 3 equals 1 times g. 9 root 3 equals g. Now let's solve for f. Again, we're going to set up ratios. 18 over 2 equals f, our short side on the left triangle, over 1, our short side on the similar triangle. We reduce it to 9 over 1, and then cross multiply. 9 times 1 equals 1 times f, so f equals 9. Now let's go to example number 2. Let's first start with a similar triangle, 30, 60, 90. It's going to look just like our triangle above. Remember, root 3 is across from the 60, 1 is across from the 30. So to find b, we start with our 9 over root 3 equals b over 1. Our 9 is the long side on the top over our long side on our similar triangle. That equals b, the short side of the triangle on the top, over 1, the short side of the triangle, our similar triangle. Cross multiply here, and we'll come up with 9 times 1 equals root 3 times b. 9 equals root 3 times b. Now we have to divide both sides by root 3 to get rid of the root 3 on the right side. We're left with 9 divided by root 3 equals b. Now I have to, what that green mark is, I'm multiplying both the top and the bottom of this fraction by root 3 because we can't have a radical in the denominator. So to get rid of the radical in the denominator, I multiply both the top and the bottom by whatever radical is on the bottom. Root 3 times root 3 gives me 9 root 3 times 9 gives me 9 root 3 on the top, and root 3 times root 3 is just 3 because that's the same as square root 3 squared. So the square root and the square cancel, and we're left with 3 on the bottom. On the top, we have 9 root 3. Well, 9 divided by 3 is 3. So 9 over 3 just becomes 3. And then our radical 3 gets carried over as well. So that equals our b. Now to find a. 9 over radical 3 equals a over 2. A is the hypotenuse, and then over 2 the hypotenuse in the similar triangle. So 18 equals a times radical 3 if we cross multiply. Now we're dividing by root 3. We get 18 root 3 equals a. Well, I can't have a radical in the denominator, so I have to multiply the top and the bottom by radical 3. And I'm left with 18 radical 3 over 3. I simplify 18 over 3. That gives me 6, and the root 3 gets carried over. So my final answer is a equals 6 root 3. Let's try one more example before I show you the shortcut on the next slide. So the first thing we need to do is set up our reference triangle on the right side, a 30, 60, 90 triangle. Root 3 is the side length across from 60. 1 is the side length across from 30, which isn't marked, but we know it's 30 because that's the missing angle. And 2 across from the 90 degrees. So let's start by solving for n by setting up our equation. 2 root 3 over 3 equals n over 1. The 2 root 3 came from the long side of the triangle on the left, and it's over root 3, which is our length of the triangle in our similar triangle, and that's equal to our short side on the left triangle, n, plus our short side on the similar triangle, 1. These are called similarity ratios. 2 root 3 over 3 can be reduced because I have a root 3 on the top and a root 3 on the bottom. So if I reduce this, I have 2 root 3 over 3. The root 3 over the root 3 cancel because it's both on the top and the bottom. So I'm just left with 2 over, which is the same thing as 2 over 1. So if I rewrite my equation, I'm left with 2 over 1 equals going back from the top, n over 1. This makes it much easier to cross multiply. So 2 times 1 equals n times 1. So I'm left with 2 equals n. Now let's solve for side length m, the hypotenuse. Two root 3 over 3 equals m, the hypotenuse on the triangle to the left, over 2, the length of the similar triangle. I can cancel out root 3 over root 3 just as I did solving for n, and then cross multiply, and I'm left with 2 times 2 equals 4 times m times 1, which is m. So my final answer is 2 equals n and 4 equals m. You might be wishing that there was a shortcut so you didn't have to set up 2 similarity equations for every single problem. Well, there is. Now, to go from the short side, 1, to the hypotenuse, 2, from 1 to 2, we multiply by 2. That's what that times 2 means. To go from the short side 1 to the long side root 3, we multiply by root 3. Let's put this in the context of a problem. First, I should mention that the opposite is also true. If I'm going from side length 2 to side length 1, instead of multiplying by 2, I now divide by 2. If I'm going from side length root 3 to side length 1, which is going from long side to short side, I then divide by root 3. The very first thing you could do is mark what your long side is, what your short side is, and what your hypotenuse is. That way you know what you're given and what you're looking for. So my long side is 3 root 3, my short side is y, and my hypotenuse is x. So I'm going to start by going from long side to short side. I always want to get the short side first. So even if I was given the hypotenuse and I needed to find the short side, I would go hypotenuse to short side before I went and found the long side. So always find the short side first. So if I'm finding long to short, I'm dividing by root 3. So 3 root 3 over 3 will give me the short side, y. Remember, root 3 over root 3 will simplify, and just to 3. So our y equals 3, and that's our short side. So now we're going from short side to hypotenuse. To go from short side to hypotenuse, we multiply by root 2. 3 times 2 equals x, which is our hypotenuse. So x equals 6. Let's look at another example. In this triangle, we are given the long side, and we need to find first the short side, and then the hypotenuse. Remember, always find the short side first if it's not given to you. To go from the long side to the short side, we have to divide by radical 3. So we're going long to short, divide by radical 3. So we're trying to find v. So 4 radical 15 over radical 3 goes from long side to short side. That equals v. We simplify 4 radical 15 over 3. Radical 15 over radical 3 is the same thing as 15 divided by 3, which is 5, okay, but it stays inside the radical. So we can work with inside of the radicals together, outside of the radicals together. So we're left with 4 radical 15 equals v. Now we want to go from the short side to the hypotenuse. Again, I can't stress enough how important it is to always go from the short side. So we take 4 radical 15 times 2, because to go from short side to hypotenuse, we multiply by 2. So 4 radical 5 times 2 is 8 radical 5. The outsides multiply together. Only the radicals get multiplied together, and the 2 doesn't have a radical. So 4 times 2 is 8. We're left with that radical 5 gets dragged along, and that equals u. Alright, let's look at one final example. In this example, we are given the hypotenuse, and we need to find first the short side, and second, the long side. So to go from hypotenuse to short side, y, we have to divide by 2. So 6 radical 3 divided by 2 will give us our short side. Now, the 6 gets divided by the 2 because those are both numbers outside of radicals. In fact, there is no radical on the denominator. So 6 divided by 2 is 3. And then that radical 3 just gets dragged along. And we're left with 3 radical 3 equals y. That's our short side. And that's important because to get to our long side, we need to use the short side. Now, to get from short side to long side, we have to multiply by radical 3. So we're left with 3 radical 3 times radical 3. Leaves us with 3 radical 9. But we know what the square root of 9 is. We know what radical 9 is. That's 3. So really we have 3 times 3 equals our long side x. In addition to doing the notes packet, I would like you to fill out the summary section about what you learned from the notes and also do problems 1 through 8.